Okay, so part 4, futuristic trends in automotive manufacturing and the factors shaping Industry 5.0. To conclude, we take a look at futuristic trends in automotive manufacturing and the factors shaping Industry 5.0. Here we explore the key factors and stakeholders that are causing a transition from Industry 4.0 to 5.0 and analyse the skills and roles of the modern automotive manufacturing workforce in Industry 5.0. So, key factors and stakeholders that are causing the transition. Stakeholders and manufacturing organisations. The key factors causing manufacturing organisations to transition from Industry 4.0 to 5.0 is that the technology is becoming more readily available and more cost efficient to automate manufacturing facilities. Industry 5.0 brings with it the ability for customers to customise or individualise products, whilst manufacturers have the ability to process these said products within the efficient processes already created. In our organisation, the two-tone car is an additional process that runs parallel to the monotone processing, creating individualised products for greater profit with little additional process. A report written by Jürgen Meyer found in UK's manufacturing sector could unlock £455 billion by 2018 if it cracks Industry 4.0, with possibly 175,000 highly skilled jobs to go along with it. Industry 5.0 is already underway, meaning these figures could well be increased. With this in mind, manufacturers are seeking increased productivity, efficiency, and most of all, consistent quality.
Governments within stakeholders with Industry 4.0 to 5.0. There's little to suggest what the UK plans are for futuristic trends within manufacturing shaping of Industry 5.0. The government looks set for a long-term plan to boost productivity and earning power for people throughout the UK, and a set industrial strategy to put UK at the forefront of the industrial of the future. Many experts already announced the 5th industrial revolution that will bring about new programs and cooperations and interactions between humans and machines. I guess 5G could be a start, as 5G has been spoken about as a future connectivity and is looking to be rolled out across the UK in 2019 and will bring a rise in uploads and download speeds.
As for regulators, at the moment there isn't a great deal of regulation with regards to Industry 5.0. Regulators, however, do have a large task on their hands in order to regulate Industry 5.0. As we have seen recently in the news, like Carl touched on, with Huawei, there is great risks involved with developing our systems further and can leave organisations and countries open to cyber attacks. This means regulators must regulate the most complex systems we have ever invented from across the whole world. Ethics is another big talking point when it comes to Industry 5.0, especially when it comes to machines making potential life or death decisions for us, all of which must be regulated for each supplier of an artificial intelligent or autonomous product.
Professional associations. So, as Industry 5.0 is in development, professional associations are coming forward to discuss their vision for the future of the next revolution. The EESC, which is the European Economics and Social Committee, are using data-driven from Industry 4.0 to shape discussions on how to proceed with 5.0 and the impact and implications of artificial intelligence. While Industry 4.0 has been seen by some as wasting human problem-solving skills, value-adding human creativity and critical and exclusively human and craftsmanship with speed, productivity and consistency of robots. As seen from Industry 4.0, many other organisations are also leading the way towards Industry 5.0, such as the UK Manufacturing Technology Centre, European Automobile Manufacturers Association, and German Association of Auto Industry BDO.
So suppliers, so going from Industry 4.0 into 5.0 is the suppliers are going to be using a lot of autonomous driverless trucks. So the smart motorways will aid the trucks, and basically the trucks will be on the roads 50% more. So currently the trucks are 25% usage on the roads with drivers. With the autonomous driverless trucks, they will increase to 75%, making it far more efficient for freight companies to transport finished goods and raw materials backwards and forwards into Industry 5.0. The digitalisation of the material will allow the scheduling of collections to run far more efficient, and therefore saving the company far more cost.
Market analysis and customer as a user contributor. Some of the futuristic trends in manufacturing that are shaping Industry 5.0 are the continuous feedback from customers in order to improve our processes and the quality of our products. This could be the evolution of customer surveys to sensors within products that send real-time data immediately back to production quality control. This could be devices within products that feedback wear and tear or performance, also giving us an overview of the customer use. Another example of this kind of market analysis could be insurance companies that have digital boxes in customers' cars to monitoring behaviour, driving behaviour, data feeding back to user information instantly. With the growing involvement of customers into production of products, the future holds more control over getting products that are more suited to the customer needs. This could be more advanced interactive configurators available for customers to explore products before they order and purchase them. This may be through virtual online platforms, giving them the ability to try out different options in the virtual world in order to make decisions of exactly what they want.
Educational institutions. So educational calls for future workers to be highly trained in emerging technologies. As these pose obviously threats for the future generations, schools and universities really need to think about the relevant skills needed within the industries. So key factors could be the knowledge of whether, when, where and how to use the technologies. Key skills to be taken into account, so they need to be problem solving, critical thinkers and going forward. Obviously this creates a shortage of demand for the upcoming skills. So obviously it's necessary to give opportunities as possible to create the context for the students to prepare for future jobs. This could be going online training, totally based within the universities, or kind of self-learning as they create different skills for themselves.
Cognitive computing. In Industry 5.0, human intelligence will be working in tandem with cognitive computing to produce more value-added products and goods. Cognitive computing will also have the ability to complete more complex tasks that were once thought to be reserved for the human mind, such as problem solving. This is going to enable quicker and potentially more efficient problem solving, and therefore reduction in waste. These systems are also going to allow full personalisation for the customer. For example, with the shoe and clothing industry, rather than the customer purchasing from the shelf, they'll be able to specify and pick colours and materials of the product for electronic assistance.
So 3D printing, obviously industries have been moving forward towards this for a number of years and introducing 3D printing into manufacturing processes. So over the years, the availability of new materials and 3D geometry enables products to be manufactured to structures that were previously impossible. So the use of 3D CAD application provides the opportunity to test designs before actually tooling's been brought and large-scale investments been made into products. So the advancements in 3D printing, they were able to recognise materials used within the manufacturing process, configure it to the requirements of the 3D printing, give maximum use of available technology, and after the 3D printing obviously have to ensure that they have the humans that are trained to enable this as well.
Jimmy.
Okay, so augmented reality. So this is an interactive system for our customers to see their products. So What we have at Rolls Royce is an after sales area where the cars can be put, and the customer can go into the dealerships all around the world and they can see their cars in their own reality. So there's two types of augmented reality, and that's mixed reality and computer modified reality.
Blockchain technology is technology whereby customers are able to see a lot of detailed information about a product, which in turn offers customers a degree of reassurance regarding the quality of the product that it is that they're buying. Popularly, this technology is popular in its deployment through QR codes on the packaging. So customers are able to scan the QR code and find out key information about the product, such as the location of cultivation, the date of harvest, the owner of the growing plot, and when it was physically packaged, i.e. full details on the entire supply chain of that product that they're buying.
Artificial intelligence, futuristic trends that are shaping Industry 5.0 are the growing applications of artificial intelligence. The ability of taking automated machines that revolutionised Industry 4.0 and developing them further to be able to make their own decisions, minimising the need for human involvement. With this level of technology, we can also expect artificial intelligence to be able to gather critical data, carry out analysis, self-learn and improve processes that they are assigned to. Another artificial intelligence example within the motoring industry that's taken shape is the concept of autonomous vehicles. These would also be able to think for themselves, self-learn and make decisions. Voice controlled user interfaces. So voice user interfaces, or VUIs, allow a user to interact with a system through voice or speech commands. Virtual assistants such as Amazon's Alexa and Apple's Siri are a great example of these interfaces. Recent work in Germany presents an implementation of such system for a humanoid interior service robot known as the Metrolabs Skitos G5. The work incorporated a natural language-based interface. Using technologies like speech recognition and speech synthesis, the robot is able to accept simple voice commands and respond to them.
Virtual reality is a computer-generated simulation of a three-dimensional image or environment that can be interacted with in a seemingly real or physical way by a person using special electronic equipment, such as a helmet with a screen inside or gloves fitted with sensors. There are, however, risks associated with virtual reality. These include a loss of spatial awareness, dizziness, disorientation, seizures, nausea, also known as cyber sickness, and eye soreness.
Integrating digital and physical techniques look to improve two key areas: operation improvements and revenue growth. Industry 5.0 is not restricted to the manufacturing sector. It will also solve social problems with the help of integrating physical and virtual spaces. Collaborating humans with smart systems is going to be a big part of Industry 5.0 to help achieve high-speed accuracy with the use of cognitive computing and critical thinking of skilled humans.
Application program interfaces outline a set of routines, protocols and standards during the construction of software applications. In basic terms, APIs outline how software components should interact on and talk to each other, and how it should be graphically represented to the human user. If a car was a software component, its API would be the information about its ability to accelerate, brake and turn on the radio. It would also include information about how to accelerate, put your foot on the gas pedal and push, and what and how information comes together in the API definition, which is the abstract and separate to the car itself. APIs differ depending on the operating system and the platform it is intended for, as well as the hardware utilised. Popular APIs include Google Maps, YouTube and Twitter.
Automation technology. Looking into Industry 5.0, the future of automation technology seems to be software that supports the efforts and digitalise the modern enterprise and control systems and machines. New software could provide comprehensive control over how applications and content are delivered to the end users. You can certainly manage and securely deliver content to PCs and other remote controlled devices. The mobile tablets reduce the dependency of paper-based reporting. the emerging of IoT, IT and OT, the operation technologies, further compliant matters, creating additional skill gaps for focusing on manufacturing and industrial operations to reshape their workforces.
So customisation, as we go towards customisation, it's a growing trend within the manufacturing industry. So the requirement for customisation and products will be required for future global markets. It gives an opportunity to wider markets or the possibilities of companies who have to adopt this principle. So, for example, modifying catalogue products for key customers. For instance, in the woodshop we use a base product which customers can customise throughout the process and think they're getting a personalised. They're paying for that personalisation, but it's basically a key component which is being added on top. The customisation market presents a drive for average sale prices. Obviously, the customisation is obviously a high cost and people are willing to pay for that. Company brands can be built on it as well, obviously using of traditional methods, but within the new technologies, enabling customisation with ease within the manufacturing process. Obviously, it's a large growing market.
Harmonisation of human intelligence and cognitive computing. Cognitive computing systems are computerised models to simulate the human cognitive process to find solutions to complex situations where the answer may be ambiguous or uncertain. One early example is the use of multi-agent systems. This consists of multiple cognitive software agents and their environment. They are used to solve problems and explore a variety of scenarios within defined environments and parameters in which the human would not have the cognitive ability to perform. These have previously been used heavily within the aviation sector to understand timings, angles and velocities of incoming and outgoing planes at an airport. More recently, automation, robotics and artificial intelligence are examples of cognitive computing. Automation can be purely software-based or integrated within a cyber physical production system, as previously discussed.
Collaborative robots, otherwise known as cobots, are industrial robots that work seamlessly and safely with humans. This type of robot has the ability to work in almost any environment, from an office environment to an automotive manufacturing facility. Collaborative robots are able to have safety guards removed due to being hand guide programmed and having specific speed and human location monitors to ensure the safety of the workers. ISO 10218 covers the requirements for a collaborative robot to ensure a safe workplace.
Mass personalisation for customers. With a growing desire to have a personalised product, manufacturing suppliers cannot go anymore. Leading companies are already implementing strategies to meet the new demand for customisation. Personalisation is to establish the right size to fit preference, personalities and lifestyle. A great example of this is the electronic devices. Customisation features which include storage capacity, processors, screen size, colour, etc. 29% of Americans say they have already got personalised products, according to Industry Week, and the demand only seems to have a positive trend. The need for mass customisation grows to produce a premium priced product relevant and meet the demand.
As technology develops, the role of the human designer is becoming more challenging. They must create technology that keeps industries moving forward whilst making sure they are secure and unable to cause damage to anyone or anything. Ethics is also something that humans are now having to design into products such as autonomous driving vehicles. For instance, if there was a situation where the vehicle was to collide with another living thing or an object, potentially putting the occupants at risk, the vehicle must be able to make the right decision ethically.
Okay, now we're going to do an analysis of the skills and roles of modern manufacturing workforce in Industry 5.0, starting with skills and strengths as a group.
So you have to speak up and just talk out what you think skills might be. What did you say? We'll start with skills?
Skills, strengths and skills, yeah.
Craft.
Yeah, especially in our organisation, craft is quite important to us, isn't it? So it's definitely a strength for us.
Okay. Creative strengths.
Flexibility, opportunity to adapt and be flexible.
I think going forward with the mass production, I think flexibility is key.
The threats, it could be unemployment.
And lack of training.
Right, so weeknesses and
Opportunities to upskill.
opportunities. Anything for weaknesses?
Inability to change, not wanting to change.
We said low skilled. Obviously, low skilled employees. Obviously, is a low weakness because it will obviously be
Okay. Are we weaknesses?
in weaknesses.
Yeah. Couple in each of them. Do we want to look at some roles?
Yeah.
Yeah.
Right, we'll start with strengths again, shall we?
IT-based roles are definitely will be strengthened.
Let's change a pen there.
And I'll mix it up, you know.
Strong leadership.
Any weaknesses?
Again, low skills. I think that falls into roles as well.
Maybe manual roles. So
Mm.
digitalisation and that. Any threats to roles?
Again, I'd probably say technological unemployment.
But then again, that's opportunity for upskilling digitally.
Yeah, yeah, that's good.
What was that one you said?
Upskilling digitally.
Oh, sorry. Happy with that?
Yeah, good.
Alright, cool. And there we are.
Just to summarise, throughout this presentation, we are seeing that the time span between each individual industrial revolution becomes smaller and smaller. Also seen a vast leap in technology and integration into manufacturing and life as we know it today. With the rate of progress of technology ever changing, Industrial 5.0 isn't far away. So, thank you.